Hi, today we're doing 4-6, which is pairs of equations. Later on you'll start to learn about these as like systems of linear equalities or something like that. But anyways, so we're looking at systems, and basically now we're going to be looking at, instead of graphing one line, it's going to be graphing two lines. That's what makes it a system. So in looking through our notes, so I want to first kind of define what systems are. So I'm going to click in here and say, so it's two linear equations. And basically by that we really mean that it's two lines that are considered together. So two lines that are part of the same problem, part of the same whatever. Um, and if the two lines cross or meet, maybe we could say, intersect, that point is the solution to the system. And kind of like how that works is this. If we have one equation, each point on this line here is going to be a different xy pair that x and y fit in that equation, make the equation work. We have the same sort of thing for our second line, that every point on this second line is going to be a xy pair that makes the equation work. So now this right here in the middle is going to be, well, that's the xy pair that works for our first equation and for our second equation. And later on in life, you learn all kinds of really cool ways, actually they are cool, to solve for this with the equations. You can do it by substitution, by linear combination, or sometimes they call it elimination, by matrices. Anyways, there's lots of really neat things. We're just going to kind of touch on the first two today that usually the books teach you, and we'll save the rest. We'll save the rest of the excitement for a little bit later. So I slipped these examples out of the books. Basically, kind of quick summary is we have this Wild World Carnival, which charges a certain amount for rides. We have a Fantastic Fair, charges a certain amount. They're trying to say for how many rides is it going to be where the cost is the same. And for this, we have an equation for each. And all right, so I pulled a couple examples from the book, and we're going to look at these. I'm going to start with this one here. I just would look at the notes. I wouldn't do the other. But we have Glenn. He's going to buy some hang gliding equipment. And there's two different ways he could go about doing it. This is going to be the cost for, like, this is if he rents the equipment. This is where he buys the equipment. And the question is, how many flights does it take for him to break even on those two things? So this first line here is going to be for the line, or for the equipment rental. That is cheaper on the outset, but then as he goes, like on one flight, what does it cost? And 2 and 3 and 4 and 5 and so on, the cost goes up because he's paying to rent every time. Well, if he were to buy the equipment, it's going to cost him $200 outright, but then it doesn't cost him quite as much to go because he doesn't need to pay to rent the equipment every time. And where does he break even? It's this point right here. That's where those two meet. So if we look at, well, what do the numbers mean? Well, then, and if we'd read the whole thing, it would probably make more sense. But the x value of 4, that's going to be the number of flights that he does. So 4 flights is where he would break even. And y is the cost for each one. So it'd be $300 for those 4 flights for both. Then after that, the buying the equipment would be cheaper because the red line, the rental, goes up faster. So if you have a graph, you're looking for where those two lines meet, and then you could do that. Sometimes, though, on a graph, especially on a graphing calculator, it's not always exactly obvious where they meet. So something that can work nicely is using a table. And I'm going to go through how to do this on graphing calculators soon. But similar thing here, we have two different carnival places and different ticket costs or whatever. So here's the equation for the Wild World Carnival, cost and number of rides. Here's for Fantastic Fair, cost and number of rides. So we could go through and say, okay, so for 0, this is what each one costs. For 1 ride, this is what each one costs. 2 rides, and so on. And if you go across, we end up with this point right here, maybe I'll just circle it, that for this x value, the x value of 4, they both cost $14. So if you get a question that says, so at what point do you break even, you look that up. Okay, so I'm going to fill in the rest of the notes here, then we'll flip over to the graphing calculators. So you can find the solution. Or by that, I really mean the intersection point. I think I wanted to write down. Yep, intersection point. That xy pair, that's the same for both. That's really sloppy. Let's make that a little bit nicer. So the intersection point by graphs or tables. And I'm going to go through how to use a graphing calculator for these next two systems. Alright, so I have here a TI-84 Plus, and it's one of the color edition ones, but this will be the same exact steps if you have a regular TI-84 Plus, TI-83, TI-83 Plus. They're pretty much all the same until you get back to like 81s or 82s or something. Okay, so first you can turn it on, this button down here at the bottom. Then if you want to type in equations, you go up here to the y equals button right there and hit that. Should bring up a bunch of different things here. So you have y1, your first y, y2, your second y, and so on. If there's anything in there, you can hit clear to clear it out. And so hit clear and then enter, and that'll take care of things. But let's go to our first equation. We have y equals 2x, so you do 2. The variable key is this one right here, x comma t comma theta comma n. So 2x minus 7, and then you can hit enter or equals. The equal sign here becomes blackened, saying it's going to graph it. The next one is negative 6x from the notes. You can't use your subtraction key. You have to use the you have to use your negative key right here for the negative 6x. So negative 6x plus 17. So you can pause the video quick if you need to get this all typed in. But if you have it, I like to sometimes hit graph first and just kind of look at what I have for these lines and see about where are they going to meet. So it draws the first line first, the second line second. So we're looking for a point right about over there. So we could try to estimate, say, okay, it looks honestly like it's a little bit past 3 and maybe a negative 1. Sometimes it's not on the screen, and then that doesn't work very well at all. But what I like doing is to get this table up here in either yellow or blue. It should say table up above the graph button. And to get that, you can press your second key over here, and then the graph. And we know that it should be about an x value of 3. Unless somebody messed up all your settings, you'll have something like this where it lists the x values. Here's the y values for the first equation. Here's the y values for the second equation, just like the table that I had in the notes. This is vertical instead of horizontal. So we think they should cross right about 3, but we're looking for what x value here has the exact same y values, the same heights. And sure enough, it's that one right here. When x is 3, my first equation gives me a negative 1, my second equation gives me a negative 1. So the answer then for this first one is going to be that point 3, negative 1. So I'd grab your notes, and underneath this, that's just kind of how you write the solution, that it's a point. So it's 3 comma negative 1 in parentheses. And if we were to now try that for the second one, I'm going to, well, if you want to get back to the normal calculator, you want to get this place here where it says quit. So you could do second and then mode. That'll get you out to a normal. Now you can do 2 plus 7. But we want to put in the new equation, so I'm going to go back to my y equals up here. Do clear equals, or enter to clear those out. I'm going to type in the new equation from the notes, 6x minus 18 equals, and 4x plus 6, enter or equals. So you might want to pause it while you get those in, or you can try to keep up. If I hit graph, now for this one, they shouldn't meet on the screen if I remember correctly. So you can't really just use the graph for that. But if you would think in your brain, you kind of continue up the blue line, continue up the red line, where about are they going to meet? It's going to be off the screen somewhere up here. But it's at least going to be at an x value that's bigger than 5, probably more like 10, 15, something like that. So now if I go second graph to get that table function selected, now I know that I want to kind of scroll down, because sometimes if you're looking at them, it's kind of hard to tell, well, these are off by 12, these are off by 10. Okay, so we're getting closer as we go down. You can kind of scroll down through here and say, okay, oh, right there. So this bottom one, when x is 12, y1 and y2 are both 54. So the solution then for that second one is going to be the point 12, comma 54. And that should be it for the notes. If you flip it over, look at the I can statements. We should have covered all those. If you have questions, let me know in class.